easy, but maybe not. Maybe you guys need to start focusing a little more. Right, Z? Should focus on that. Watch where you're walking out by your car, too. Oh, it's slippery. Make sure you're all right. All right, so this week we're doing section 4-5. We will have a quiz on Thursday. Okay, so if you have an equation where both sides have the same base, b to something equals b to something. If these two numbers are the same, the bases are the same, that means the exponents have to be equal, right? And our base will never be, or will always be positive, and it won't be 1. Okay? So, if you can write both sides with the same base, it makes it real easy. There's 2 ways to do these. I'll show you both ways. The second way is when most people decide to do, because you don't have to try to think, can I write 32 with a base of 2? Okay? And you can. 2 to the 5th is 32. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. Okay, but you don't have to do it this way. But this is one of the ways that you can do it. If these are the same, like we just wrote, what's that mean about the 2 exponents? If those 2 things are equal. They got to be equal, right? Does that make sense? If these are the same number, right, and these 2 sides are equal, that means the 2 exponents have to be equal. So all you have to do is go x plus 1 equals 5. Subtract 1, and the answer is 4. Okay? If you like doing it that way, that's great. Okay? But you don't have to. You can take the log of both sides. All right? The second way, which is the way that most kids end up doing them, is saying the log of 2 to the x plus 1 power equals the log of 32. Okay? This is the way most kids will do it, because they don't have to try to think, can I write this number on the right with the same base? You don't have to think about that process. Just take the log of both sides. Now, there's a rule, a property of logarithms that says I can do what with that exponent? Move it out front, right? When we were expanding, right, we had a rule there for logs that says I can take the exponent of the number and put it out in front of the log. So this could be x plus 1 times the log of 2 equals the log of 32. Okay? And then what you do is you take the log on the left side over to the right side. So how do I move this log of 2 over? Divide it, right? Because this is x plus 1 times the log of 2. So to move the log of 2, I divide. That'll cancel. That leaves me x plus 1 on the left. When I put this in my calculator, guess what you get? You get 5. So you'll get the same thing here as x plus 1 equals 5. Subtract the 1, and you get x is 4. Okay? Just remember, when you put that in your calculator, log of 32 divided by log of 2, you got to close it off. I don't know if some of us on our quiz the other day might have forgot that part. Log of 32. Remember, you hit the log button, that left parenthesis comes in, so you got to close it off. Divided by log of 2. Close it off. And then there's that 5. Okay? So the one on the second way I showed you is what most kids will do, because they don't have to go through the thing, doing that guess and check or whatever you will do to try to figure out, if that number on the right side I can write with the same base. But if you like that, if you can do that quickly, that's a little bit quicker. All right, this one you can't do that way. I cannot write 40 as 5 to some power. So I have to do the log part. Okay, so you take the log both sides, log of 5 to the x equals log of 40. And the rule is I can move the x out front and multiply it by the log. And then move the log on the left to the other side by dividing it. So then I get x equals whatever that cancels. I get whatever that is. And it's not always going to be a whole number like that first one. Just go log of 40, close it off, divided by log of 5. Close it off. So you get 2.29. We'll just go to the hundreds. It's okay to get a decimal. So normally most kids will do that. And this one we have to do that because I cannot write 40 as 5 to some power. 5 to the first is 5, 5 squared is 25, 5 cubed is 125. So if I go 5, if you want to check, you can go 5 caret answer. So check if you want. Those two examples make sense? Okay. So basically, if it's an exponential problem, we turn it into logarithms. All right. Again, this one we're going to have to take the log of both sides. All right. So usually what I do, we get in the habit, we know that we're going to move the exponent out front of the log. So I do that, my first step. I move that exponent out front, and then I'm taking the log of both sides. I'm going to move the log of 3 to the other side by dividing it. So on the left, it's 2x minus 1. And on the right, it's going to be some number times x plus 2. All right? So log of 5 divided by log of 3 is at 1.46. Okay, I have to distribute that. And I go times 2 for that part. 2.93 if we round it. So we're going to be a little bit off, but that's okay. All right, so what I'm going to do is take the 1.46 to the other side. So I'm going to subtract it. I'm going to add the 1 to get it over here. So that canceled, and the 1's canceled. Over here is 3.93, 2.93 and 1. And 2 minus 1.46, 0.54x. And divide. So 3.93. Again, we're going to be a little bit off because, so we can say 7.3, I guess. We're going to get something like that. All right. Every now and then you might get a quadratic. All right. If you get a quadratic, you just use quadratic formula to solve it. All right. Not too often you'll get that on the exponential ones. So we're going to turn them into logs. Just take the log of both sides, move the exponent out front, take the log on the left over to the right by dividing, and then solve it. Questions on exponentials? Stir me? You awake? All right. The other type we're doing in this section is logarithmic ones. And there's just another one of those. All right. So when they were exponential, we took the log of both sides. When they're logarithmic, we're going to turn them into exponentials. So the one on the left, what's the base? Exact same. Thank you. So we're going to rewrite it as 3x minus 5 equals 10 squared. That's how you turn it into an exponential, right? You're supposed to know that. What is 10 squared? 100. So add 5, you get 105, and divide by 3, and you're done. What's that, 35? Okay. So once we just got done doing exponentials, we take log of both sides. When we see a log problem, we're going to turn it into an exponential. So Nathan, what's my equation for the one on the right? What's my exponential equation?
Minus 1 equals 5.
Very good. Now this time the base is 5. So the number after the log, we just leave, and whatever this base is, we raise to that power for the other side. Well, 5 to the third is 5 times 5 times 5, which is 125. And then just solve for x. Once we get to here, it's pretty easy to do. What's that, 14? Again, they won't always come out to whole numbers real nice. That's okay. Those two examples make sense? Eaton, making sense to you? You sure? All right, what about if you have multiple logs? What did we learn? Yeah, we want it to be a single log to do what we've been doing here on these two. These are single logs. So what do I do to these two to make them single logs? How do we condense them? When it's subtraction, what are we supposed to do? Divide. When it's addition, what are we supposed to do? Multiply, right? Okay? So, I'm going to write log of 2x divided by x minus 3 equals 1. So if you have multiple logs, you're going to condense it into a single log like you're supposed to know how to do. Some of you didn't know so well on the quiz. And then do what we've just been doing. What's the base of this one, Connor?
X minus 3.
No, the base, not the denominator. What's the base? So that log.
2x.
That's the numerator.
All right, there's one number left. Yeah.
Now the 1 wouldn't be the base either.
Well,
What was the base when we did this one?
3x. No, 10 squared.
Yeah. Okay. So what's this side going to be?
1 squared.
Not 1 squared.
Yeah.
What's this base? Come on, wake up. You run so fast you can't think about bases now, huh? What did we just say? There's no number. What was it? What did we use?
10.
All right. So what? There's no number again. So what's the base?
10
10. What's the exponent?
squared.
No. What's that number?
1.
Yeah. Come on. Focus. How do I get that x minus 3 out of the bottom there, Andrew? When I want to solve for x, I got to move that out of the bottom. How do I move it out of there? Yeah. What do I do with it? Did you say? Yeah. Multiply. Good. So I gotta multiply both sides by x minus 3 to move this out of the bottom. So I get 2x equals 10x, because 10 of the first is 10 minus 30. You guys okay with that? Should be able to handle that. Subtract 10x. Get the x's together. I get negative 8x equals negative 30, and then divide by negative 8. And I get x equals a positive 15/4, which is what? 3.75. Okay. So I had two logs to start. There was subtraction between them. So to make it a single log, I did division. So then I could write my exponential. This number, this fraction equals 10 to the first power. All right, so this blue one, instead of dividing to put these two together, what do I have to do? You guys already told me. Multiply them, right? What's the base again? 10 again. Now, will it always be 10? No. Whatever, if there's no number there, the base is 10. It's whatever this is to that power is what this number equals. Well, let's go ahead and distribute. All right, now it turned into a quadratic. It turned into an x squared. Okay, so I'm going to have to set it equal to 0 to solve it. 10 squared is 100. When I bring it over, I'm going to subtract it. Now, there's different ways. You can use the quadratic formula. That might be best for some of you. That's fine. But this factors, I believe, into x plus 20 and x minus 5. 20 times negative 5 is negative 100, and 20 plus a negative 5 is 15. So what's this answer? Negative 20, right? What's this answer? 5. Now, we go check. All right? It says log of negative 20. Can you do that? Log the negative 20. Yes or no? No. So you check on those. When you get multiple answers, you check in the original problem. You can't take the log of a negative. So that's a no good answer. The only one we can use is that one. All right? So log of 5 plus log of 20. See what we get. Clear it up. Log of 5 plus log of 20. Yeah, it's okay. Supposed to be equal to, right? We got the right answer. So you're going to get a few problems where you won't have a single log. All right? This one, subtraction, we made division. We learned that last week. Addition, we made multiplication. We also learned that. You should know how to condense it. All right, once in a while, you'll have them on both sides. So condense this to a single log. Since it's addition, I'm going to multiply these two. So the natural log of something equals the natural log of something else. What must be true about these two things? What do you think? I heard it, I thought. The natural log of some number is equal to the natural log of another number. What do we know about those two numbers? They got to be equal, right? That makes sense? Common sense? So that's what you do then. So if you have one on each side, you just say whatever comes after the logs are equal. So here was multiple logs. We had to multiply to make it a single log. And then we can just drop the logs. We just solve it like you're used to solve. Now, again, the one on the right here is gonna get us an x squared when I FOIL that. 2x squared minus 4x plus 2x minus 4. Okay, so I got an x squared in here. I'll have to set it equal to 0. So I'm gonna bring these two to the right side. So the left side's nothing. So I got 2x squared. Negative 4 plus 2 is a negative 2, minus 3 is a negative 5. Negative 4 and a negative 8 is a negative 12. Okay, this I think will factor, but you can use the quadratic formula if you want. We'll just go do that since we haven't done that for a while, just to show you again. X equals negative b plus or minus b squared minus 4 ac all over 2a. Some of you like that better than factoring. There's nothing wrong with that. That's just another way we learn to solve a quadratic. So I get 5 minus a negative plus or minus 2 times 2 is 4. All right, negative 5 squared is a positive 25. Negative 4 times 2 is a negative 8 times negative 12 is a positive 96, I believe. When I add those, I get 121. What's square root of 121? 11, right? I guess I'll put that there. All right, so I got 5 plus 11 is 16 divided by 4 would be 4. And 5 minus 11 is a negative 6. Divided by 4 is a negative 3 halves. All right, so let's go back to the original problem. 4 and a negative 3 halves. All right. 3 times 4 is 12, plus 8 is 20. 2 times 4 is 8, plus 2 is 10. 4 minus 2 is 2. So I don't get any negatives in the parentheses, so 4 should be fine. Okay? And then a negative 3 halves was the other one, right? That's negative 4 1/2, because that's negative 1 1/2. So 3 times negative 1 1/2 is a negative 4 1/2. Plus 8 would still be positive, so this side's okay. 2 times negative 1 1/2 would be negative 3 plus 2 would be a negative 1. I can't take it. I can't take the natural log of a negative. So that negative 1 doesn't work because I'd be trying to take the natural log of a negative. All right, a lot of times that happens. One of them works, one of them doesn't. But you got to check in the original. What's the base for natural log? What's the base? Somebody knows. I heard it louder. E, right. That E value, right? There's a natural log button right under your log button. Okay? So, if you have to do that. All right? So, back to what we looked at first. What would I do to both sides to solve this? Come on. Take the log of both sides. What happens to that 2x plus 3 then? What happens to it? It comes out front, right? So the log of 10, we're going to divide into the log of 315. And then 2x plus 3 is going to equal that answer. Okay? And then, so exponential ones, we turn into logs. Log ones, we turn into exponentials. If there's no number, the base is 10, right, Connor? So this base to that power equals whatever came after the log. That's how you set it up. Just solve. Okay, multiple logs, make them single logs. You got a log on each side, just drop your log. There's your homework. You got almost 20 minutes. Simple. And Harry, you've been looking at your phone the whole time? I'm going to take it from you.